ACE math.
The free response on AP Classroom should have already been completed.
Oh, okay, never mind.
Yeah. The goal was that it should take us about 3 days to do AP Classroom, 1.5-ish to 2 on multiple choice, and 1 on free response. But a lot of people have not been doing stuff, so it's been taking longer on that. And then we were going to do the ACE Math stuff today. Clearly, we did not get that deadline because just the way everything's worked out. But it's not a big deal. But I need people to be working as well. So let's see, did we do 9?
Yes.
Yeah, we did that one. Okay, so 10. General point switch defining statements provides justification for concavity. So obviously we need the second derivative. Do any of these answer choices not match up? Concave down, no, those all match up. Okay, so basically if you find the second derivative, you're going to be able to figure out which one it is because they're all different. Okay. Okay, so do I need to show how to find the second derivative for everybody?
Yeah, I got it wrong.
Okay, that's fine. Before I even do that, what is the x squared plus y squared equals 36? Does anybody know what that is?
The circle.
Yeah, it's a circle. Doesn't have any bearing on the problem. That was just a general question. All right, so first derivative, remember this is implicit differentiation. So when I go to take the derivative of that y squared, you have to be careful. We've been doing it for a couple of days, so I don't think that'll be an issue. Also, don't forget the right-hand side. One of the big mistakes, again, is not making that 36 turn into a 0 when you take the derivative. So you get that.
Wait, I thought the 36 was supposed to be a 0.
When you take the derivative of it, it is. That's what I said.
Oh, okay. I thought you said it wasn't, and I was like, what?
I said make sure you turn it into a 0. That's a big mistake that people make, is not making a 0. So it'd be what, negative x. So y prime, when you move the negative 2x or subtract 2x and divide by 2y, you get simplified down to negative x over y. Then when you go to do the y double prime, quotient rule. I'm going to move the negative up top with the x just to make my life a lot simpler, so I know that's negative x, so I don't mess with my signs. Otherwise, you'll run into issues. So you get low d high, so you get negative y minus high d low, so negative x times y prime over low squared. Replace the y prime with our answer up here, because we do have to substitute that in, and we get negative y minus x squared over y squared. I think that's right. Negative, 3 negatives mixed in. Yeah, okay. Again, notice how we're going to need to get their answer, so we're going to...
Wait, wouldn't it be plus x squared?
No, because you have the negative from y prime, the negative from x, and the minus negative, so you get 3 negatives. So it's minus.
Oh, okay.
So multiply through by y to get rid of that, so you get minus y squared minus x squared over y cubed. Yep. And I'm assuming this is where probably most of you stopped and didn't know
Where
what to
did
do.
you get? Wait, how did you get the y squared?
I multiply everything by y over y.
Oh, okay.
So you get rid of the fraction, because if you notice their answers, none of them have fractions in it. So I know how to do something, and that's always a good thing to do, is get rid of the fraction inside of a fraction. I'm assuming this is probably where most of you stopped and didn't know what to do from there. However, if we look, just like we talked about yesterday, this y squared, negative y squared minus x squared, I can rewrite that as negative. I'm going to rearrange it just to make it a little easier to see. Is negative x squared plus y squared, which we look up at the top, and that is 36. So our answer is negative 36 over y cubed. Okay, so the answer should be C. Yep. Now, if I look at C versus D, why is it C and not D?
Because it's not concave up.
Because it's negative.
Negative.
What happens if I multiply both sides by negative, though?
And then one of the sides is negative.
But what do I do in an inequality when I multiply it by a negative?
You
flip the sign.
I flip the sign. So D is correct. That is not a wrong statement. However, when I plug into my second derivative, do I get a negative number or do I get a positive number?
A pause.
If you look at the top, it tells you y is greater than
Greater
0.
than 0.
So if I plug in a number to y that's greater than 0, I need to get a negative value for my second derivative. So the second derivative is concave down. That's why it's C and not D. If y had been negative, then it would have been concave up because my graph would be concave up there. So very nicely, and this is where I said it doesn't really matter, but it does help you out. If you know this is the graph of a circle, and we're only looking where y is positive, that's your graph. What do we know about that graph the entire time?
It's always positive.
We're looking at concavity though.
Oh, it's always concave down.
So the graph is always concave down. So you know the answer had to be one of the two concave down answers. So there's things that they hide in there that if you're paying attention will help you out if you know certain things. Now, was that necessary for the problem? No. Does it help? Yes. Do I need to do number 11?
Yeah.
Okay. So we have the point we're just looking for basically the first derivative, second derivative values. So I'll take both derivatives, which I'm assuming is where you probably ran into an issue as you made a mistake on not being careful. So we do have a product rule. It was x squared y cubed, right?
Yes.
Equals like 576. So
Yes.
first derivative is 2x y cubed plus 3x squared y prime equals 0. Okay, I'm going to leave it like that, and you'll see why in a second. I'm going to take a derivative again. Actually, no. Yeah, I'll do quotient rule. Quotient rule will be a lot easier. So you get y prime is equal to negative 2x y cubed over 3x squared y squared. So I don't know if you'll be able to see the red or not, but that goes away, that goes away, that all goes away, and that goes away. So you get negative 2y over 3x. And then take its derivative, y double prime, negative 6x minus negative 2y times 3 over 9x squared. Negative 6x plus 6y over. So those should be your two derivatives, and then just plug in your values. Ooh, I made a mistake. Somebody find it. I'll give you a hint. It's on the last line.
Wait, there's no like prime in the quotient rule.
There you go. Good job, Manuel. So I forgot to do y prime when I did the derivative of this, so I need a y prime there. So very good job. That was a mistake on my part. Top derivative of the top is negative 2y prime. Now I'll talk about y prime. Okay. So at this point, you just plug in your, what, negative 3 and 4 everywhere. So I would obviously do the y prime first. So we get that y prime is equal to, what did I say those numbers were? Negative 2, 4? Negative 3, 4?
Negative 3, 4?
Negative 3, 4. So you get
Yes, negative 3, 4.
8/9 at negative 3, 4. So I get a positive value for that. Did I do that right? I did. Okay. And then you plug in everything here. The difference is you have to plug in a y prime value. Well, we know what y prime is. You know it's 8/9. You can either plug this in and then plug in all your x's and y's, or you can just plug in the -3/4. But since we know this is 8/9, you get that y double prime is -6, x is -3, y prime is 8/9, y is 4 over 9 times -3 squared. And again, we only care if it's positive or negative, so bottom is always positive, so that's irrelevant. I should ask myself, is the top positive or negative? You should be able to quite easily see that it's a positive plus a positive, so it's positive. I don't care what the actual value is. Any questions on anything I did anyway? Okay. Number 12. Okay, so if we're given the derivative and we're looking for a max or a min, clearly this kind of helps us point in the direction of what should I be using for this question. What should I be using to determine a max or a min if I'm given the derivative and a critical?
The second derivative.
So I could use a couple of things. I can use number line, or I could be using second derivative test. Clearly, looking at these answer choices, I cannot use the first derivative test. I should be using the second derivative test instead. Especially because of how the derivative is defined. The derivative is defined in two variables. So you definitely want to be using that second derivative test there. You would not want to use a number line because that would become actually really hard because you don't know how to do that. So take your second derivative and then plug in the point. Clearly the dy dx is 0 if you plug in 0, -2, so that's easily, it's on all of them. So you're really just asking yourself, is the second derivative positive or negative? And then does that tell you have a max or a min? And just go from there. So the answer, so if you, do I need to take second derivative for anybody?
Nah.
Okay. So you should get, the second derivative is negative. If the second derivative is negative, does that mean you have a max or a min?
Max.
That's a max, so the answer is D. Any questions on that one? Okay, going to free response part A. Alright, they are giving me an f prime value, so they're giving me a critical point. They're giving me the second derivative, okay. On what open intervals is the graph, how do you determine concave up?
Second derivative.
Something.
A little more
second derivative is
detailed
positive
there.
and negative.
There you go. But specifically we're looking for concave up, so are we looking for positive or are we looking for negative?
Positive.
Concave up is positive. So you're basically just asking where's the second derivative negative. Well, they gave me the second derivative, so all I have to do is figure out where's that positive, where's that negative. Well, how do I figure that out?
Plug in values.
What values?
They're critical values.
Critical value.
That would be a terrible idea.
Oh.
That's for maxes and mins, by the way.
Yeah.
Numbers in the interval.
No, you would never just randomly plug numbers in the interval in. Guys, you graph it. Graph the function.
Oh, that would make sense.
It's a calculator enabled question. They're not going to give you x squared plus cosine x squared of cosine x squared plus pi and ask you to do these things by hand. There is some extent to where you're not going to be doing things by hand. All you do is put in the graphing calculator and see where it's above the x-axis.
Not gonna lie, anytime I see a trig function, I kind of always put it in the calculator.
Fortunately, this is a calculator-enabled entire test this year for reason.
Oh,
Yeah.
But yeah, you just graph on the graphing calculator and see where it's above the x-axis. Now to do that, you will need to calculate zeros to figure out what those values are. Because you're going to have to label them out. If it was multiple choice, you just kind of need to eyeball it and that'd be fine. But here you will need to calculate those actual values. You should have calculated the values 1.253, 2.170, 2.802, and then 3 was the ending point. So those are the numbers you should have calculated. Does anybody need me to show that part out?
Probably.
Do you not remember how to calculate zeros on the calculator, Deborah?
Oh, I know how to do that. That's just
what
not
he
what I
asked,
did.
bro.
So.
Literally what I asked. Do I need to show the calculating zeros? And you're like,
Well,
probably. So put that in the graphing calculator. Make sure your calculator is in radians, and then calculate those zeros. And then
At this
basically
point, will
just,
it ever be in degrees? Unless it just like does it by itself.
well, some people take physics, so
Well, that's a stupid idea if you ask me.
that's only because
I
you
agree
failed twice.
wholeheartedly.
Miguel, you have no
Yeah,
choice. You're taking physics next year.
I mean, that's what you think. What
Yeah,
if there is no next year? What if we all die, huh?
We are on stream, so please keep that to the low.
Yeah,
Oh, darn it.
I'd really rather not be banned from Twitch.
What if we die? Gets a shadow ban.
All right, so just put that on the calculator, calculate your zeros, go from there. That's pretty easy. Part B, we've talked about this a few times. How do we determine maximums and minimums? Somebody give me one of the two
God,
options.
that's the worst thing I've ever seen.
Find the critical value.
Okay, so somebody give me one of two ways. So you guys are all mentioning stuff that's useful in doing what we need to, but there are one of two options. You should always be thinking about this. What are my options?
This is the worst graph I've ever seen in my entire life.
Okay, well, look at your face and then compare.
No, this
so
is worse.
that's pretty bad then.
Do you not see it? It's literally just the whole screen is just blue.
Change your window from -1 to 1 or -1 to 3
Well,
and your Y's.
I mean, but it's
Okay.
still just like.
I can't help that. I never graphed it. So thank you, Miss Bridget. You do the first derivative test or the second derivative test. We cannot use one of them. Which one can we not use here?
The first derivative test?
Why can I not use the first derivative test?
Because we don't have the first derivative?
The first derivative.
Correct. We don't have the first derivative. All
There's
we know
no way we're going to get the
is
first
that,
derivative.
no, you're not anti-differentiating
Yeah.
that. The only way that we can do anything is by knowing that the first derivative is equal to 0. So we then plug that into our second derivative and either get a positive number or a negative number, and that will tell us if it's a max or a min. If we get 0, that is neither at that point. So if both the first derivative and the second derivative is 0, that's a neither. So just plug in 1 to your second derivative because you already have it in your graphing calculator, so you can do all that by the graphing calculator. Use your chart, however you want to do it. And you get that it is a negative value, so therefore you have a relative maximum at x equals 1 because the second derivative, be careful, in your justification you need to say because the first derivative is 0 and the second derivative is negative, you have a relative max. You do need to state both of those things. So if you're not stating both of those things, make sure you make notes to yourself. You have to tell me that the first derivative is 0. Because they gave that to you, that's fine. However, if you don't state that, you're not stating the requirements for the second derivative test. Second derivative test is you must have a critical point. So you have to then say, so you have to include that in your reasoning. It's the whole idea, like if they tell you it's differentiable, you also have to tell them it's continuous. We can't assume that you know that is a requirement. You have to tell us you know it is. And speaking of which, mean value theorem.
I actually had to look this one up.
Oh, C is a pain. I did this one on BC yesterday.
That was a pain.
C is a giant pain in the ass.
Yeah,
I'm not gonna lie. So they're kind of misleading. So you're actually using the mean value theorem on F prime here. The whole hint that you're not using it on F is we have 0 ideas about anything about F. So it's definitely very difficult. You have to use F prime and do its whatchamacallit, mean value theorem for it. So basically what they wanted you to show, and honestly I don't expect very many, if anybody, to have gotten this, and not just you guys, like nationwide. This is that, like, oh my god, this is a dumb question type thing that gets an average of like 1 or 2 points on the AP exam. So what was it? -1 to 1, 2.5. So basically what they wanted you to show was that f double prime of C, if I'm using mean value theorem, is f prime of B minus f prime of A over B minus A. This is what they wanted you to use, is this concept here, where you can use the mean value theorem on the second derivative using the first derivative. And that's really what they wanted you to kind of show, was that this is not possible. So what you would do is they're saying that it can't be that, so you kind of go, oh, f double prime of C is equal to f prime of 1 minus f prime of -1 over 1 minus -1. And this ends up equaling, so they're telling you that it can't equal, what, 2.5?
Yeah.
And we know f of 1 is 0. So you get 0 minus like 2.5 over 2, which is like negative, what, 5/4? So basically you're showing that that never equals that, is what you're trying to show. If I did all my things right there, I guess I did, okay. And you're supposed to show that the graph of x squared cosine x, can never equal negative 5/4 on that interval. It's a definitely difficult question. I'm not going to lie. And I'll freely admit this. I don't know if I would have got it on my own, just by looking at it without some at least extensive, like, sitting down and thinking type idea of what they wanted me to show, because it's not very self-evident. So this is definitely a difficult question. So don't read too much into it if you had no idea what was going on, because, like I said, I don't know if I would have got it had I not, like, looked over at the answer key when they were doing some stuff, because it looks very simple on the outset. Oh, use MVT, no big deal. But you have to realize you're using MVT on the second derivative function. So it's definitely a jump in difficulty. C is quite hard. But then you get down to part D, and D is super easy. So yeah, I don't understand why they did that in that order or anything. But how do we determine a point of inflection? Somebody remind us again.
If it's 0 under
it
5.
changes.
So
Wait.
you have to be careful. If it's 0 or
Change the sign.
undefined, does not tell you it's a point of inflection. Points of inflection have to change sign.
Yeah,
No, that was my bad. I was doing critical point.
Well, it technically is a critical point of the second derivative, but it takes a step further, and it's not just the critical points. It actually has to change. And that's the thing that you got to remember as that definition. So you do find the critical points of the second derivative, but then on top of that, it also has to change. So not all critical points of your second derivative will be points of inflection.
Okay.
In this case, if you do your number line, so you're doing a number line on the second derivative, you've already got it graphed. You could actually just look at the point on the graph. To be honest, you don't have to do a number line or anything. I would, when it says give a reason for my answer, I would kind of have the number line sitting there just to, like, show, hey, I'm referencing this. But basically, the answer is no, because it does not change sign. Apparently, I don't know if it bounces off or what it does at 0. I don't know, but it doesn't change sign at 0. So the answer is no. So realistically, most of this question relatively easy, as far as what I would say. Most of you are able to get something. Remember, it's always a point game. It's not you got to get everything right. You can do part of A, part of B, and part of D without a problem. C is that what the heck is going on here question. And like I said, I'm not gonna lie, that's a very difficult question on the outset. I don't imagine very many people across the nation got that correct as far as students go. Like, legitimately, like, at all. I would like to see these students that got that right, because that's impressive. All right, moving on to part B. I think these were relatively easy too, if I remember. At least the BC ones were. Okay, so they gave us a graph and a function. Okay. Find the x-coordinate of each critical point. This is calculator, non-calculator, no calculator. Okay. Its location is relative. Okay, so how do you determine critical points again for F?
If it's 0 undefined at a point.
What rule did Deborah just break somebody?
It. Well, where f prime is equal to 0 or undefined.
Yay. Okay, so you just set the f prime, since they gave us f prime on part A, you just set f prime equal to 0. So you should end up with 2 critical points. Square root of 5 halves, or square root of 5 over 2, and negative square root of 5 over 2. So when looking at this, you hopefully should know e to the x. Can e to the x ever equal 0?
That is not what I got.
Okay, well, I'll show you in a second. So e to the x can never equal 0. So when you go to set that equal to 0, you do just like you would for multiplying things. You set both parts equal to 0. Well, e to the x can never equal 0. You should know what that graph looks like. We've talked about it in the past couple of days, actually. But that can never equal 0. So all you have to do is set x squared minus 5 fourths equal to 0. So x squared minus 5 fourths equals 0. So x squared equals 5 fourths. So x is equal to plus or minus square root of 5 fourths, which is equal to plus or minus square root of 5 over 2. Obviously, it's for response. The first one is perfectly valid. Square root of 5 over 4 is fine. I would simplify it personally, but you don't have to. So we got our critical points. Now how do we determine if they're maxes or mins?
You can either do a number line or.
So you can do your number line or second derivative. Personally, I would highly suggest a number line because I don't want to take the derivative of that product rule and then try plugging in square roots without a calculator. So that's why it's not very nice and easy. So what I would do is a nice little number line. Do I have any kind of restrictions on the domain in this question anywhere?
-3 to 3.
That's just for G.
Oh.
Okay, so no, so I don't have to put anything on there. So we know that, well, that could, so yeah, doesn't matter. So you have negative square root of 5 over 2, and then square root of 5 over 2. So you're plugging in values into your original at that point to see if it's positive or negative. And again, this is where it's really helpful. What do I know about e to the x?
Positive.
It's always positive, so I don't even need to consider it. I only need to look at the inside. So for instance, I could pick like 0. If I plug 0 in, the inside is negative, so the whole thing's negative. If I plug in super big numbers, positive. Or if I plug in super big negative numbers, it's still positive because I'm squaring it. So your number line should be positive, negative, positive. So that means I have what at negative square root of 5 over 2?
A maximum.
And at square root of 5 over 2.
Minimum.
Thank you, Miguel.
As
You okay there, Deb?
yeah.
So it goes from positive to negative, giving you a maximum at negative square root of 5 over 2, and it goes from a negative to a positive at square root of 5 over 2. So you need to include that in your justification. You would need to say that there is a maximum at negative square root of 5 over 2 because f prime of x changes from positive to negative. And then same thing for square root of 5 over 2, except for it changes from negative to positive, therefore it's a minimum. These are all things you got to make sure you include. But relatively easy problem. That's pretty straightforward. They gave you the derivative. No big deal there, hopefully. Part B we've already talked about. Oh crap, we gotta take the derivative. Points of inflection, so we do actually have to take this derivative. Jesus. Right. So let's go ahead and I'll do that because I'm sure that needs to be done. So it is a product rule, not the worst product rule, but it is a product rule. So this is f prime. So f double prime will be, so derivative of the first one, so that's 2x e to the x plus e to the x squared minus 5 fourths. And then we're asked to find points of inflection. So we are going to need to simplify and factor this out. So you get e to the x, 2x plus x squared minus 5 fourths. If we're setting that equal to 0, again, we're going to split these up. this can never be equal to 0, so it's getting discounted completely again. So we get x squared plus 2x minus 5 fourths equals 0. I'm sure most of you probably struggled with that, and which means you probably struggled with your Cambridge stuff if you've looked at it because it's quadratics. Any suggestions on how to solve that equation? Anybody have any suggestions how they would solve that?
Trial
I'd
and
just give
error.
up personally.
Trial and error or give up. Both of those are terrible options.
Quadratic formula.
There is quadratic formula. Most of you should resort to the quadratic formula because it's straightforward, it's easy, you can do it every single time. I personally would multiply through by 4. Why am I multiplying through by 4? Before you
Get
see
rid
the
of
board.
fraction.
Get rid of your fraction. That is now possibly a factorable equation. Even if it's not factorable, it's much easier to do the quadratic on that than it is to have a 5/4 in my quadratic.
That's hard.
So I would do that and see if this factors. I'm pretty sure it does end up factoring because it's a non-calculator question. So I'm thinking, what, 2x and 2x maybe? Yep, minus 5 plus 1 equals 0. So x is equal to 5 halves and negative 1 half. Now, even if you don't see the factoring because you're not proficient with it, that's fine. I would still multiply through by 4 instead of doing actually the quadratic does end up being pretty nice. They're not terribly mean to you, but I would see if it's factorable first by multiplying through by 4. It does make the factoring a little bit harder. You can do the factoring by any method you want as long as it's mathematically valid, and then you get those. The factoring part to me is actually a lot easier because you have to figure out if it changes sign. So I don't know. And you end up getting both of them change sign. So both of them do have points. They are both points of inflection.
Wait,
What?
wouldn't it be plus 5 and minus 1?
Oh yeah. Thank you for paying attention. Thank you, Deborah.
Yeah. There's one thing I'm good at, it's factoring. Because that's all I did in college algebra.
That's all we did in college algebra.
That's all
Yeah, I
you're
know,
supposed to do in
stupid.
college algebra. C, moving on to C. Any questions on that? You would do your number line there and it changes sign at both.
What are the answers?
I just told you it changes sign at both. So they're both
Okay, but
points of inflection. Negative 5 halves and 1 half are points of inflection because it changes sign. And by it, I mean second derivative. Part C, relatively easy. Because you're given the graph of g, so they're basically asking you about questions about the derivative and second derivative. So looking at that graph in between negative 3 and 0, is g prime positive or negative? Don't make me call on people, especially people who don't answer things often. So, easy question, looking at the graph, is g prime positive or negative?
Positive.
Positive.
Why is
Yeah,
it
I'm going
positive?
positive.
I
The
need a
slope
reasoning.
is increasing.
Ooh, that is a bad answer.
That is so sad.
Dang.
So, Kayla said because the slope is increasing. That is an incorrect justification. Now, it's not a wrong answer. It's a wrong justification. So, you have to say because the slope is positive or the function is increasing. Those two things are perfectly fine. But if you say the slope is increasing, you're actually talking about the second derivative. You're talking about the rate of change of the derivative. Which leads us to part G double prime. Is G double prime positive or negative? Okay, what is G double prime? The second derivative tells us what.
Concavity.
Concavity.
So is that graph concave up or down?
Up.
Up.
So its second derivative is
Positive.
Positive.
positive. Very easy question. Now, the other justification is the one that Kayla actually gave, is that the slope is increasing. I would not suggest using that as your justification. I would much rather say you can look at the graph and tell it's concave up in this case. That's an easier justification. What about the first derivative from 0 to 3 of that graph?
Still positive.
So the slope's still positive. So the first derivative is positive.
Positive.
What about the second derivative?
Negative.
Why is it negative?
Because it's
Concave down.
concave down.
It's concave down. Very good. All right. We will have to end class there. So we'll finish going over the last little bit of D and then 2 on Monday, as well as I will be assigning whatever the next unit is. I have to look and see what all we've done over the weekend. So make sure you're working on all the stuff you're supposed to. We'll talk about exactly what I want done when I look at everything and see how much work is there. I will tell you exactly what I want done by when next week. Be a reminder, so be looking for that so you know what you need to do over the weekend.
Alrighty.
This weekend's Easter.
Yep.
Hey,
This weekend
Barrett's
is
class
Easter.
canceled class, guys.
Hey, I told you.